Okay, welcome to this next video. This is going to be on hypothesis testing. Now, this video on hypothesis testing is going to cover everything you possibly need for A-level maths. Now, in further maths, you'll learn about chi-square testing. I don't want to look at that in this video because it's just for A-level maths. So we're looking at the binomial hypothesis testing. We're going to be looking at normal approximations, pretty much everything in that realm. However, I'm not going to be explaining a lot of the keywords because this is a revision video. So the keywords, significance level,
just to be make sure I'm completely clear on this point. The revision video is basically expecting you've covered this content in the A-level statistics part of the A-level maths course. It is applied to all examples, so we'll cover specific bits for specific examples as I go through. This video might be excessively long, but if it's a complete revision video for a certain topic, then I'd rather spend the time to get that done. Okay, let's get right back to the video and carry on with some binomial hypothesis testing to start with. Then on to some OCR MEI stuff as well. So let's go back to the video, enjoy this one.
Null hypothesis, the alternative hypothesis. I expect you probably know what I'm going on about there. Okay, so you need to go and watch a full video, which I'll put up later on, and then you can come back to this and you can watch this video. So that's the plan anyway. That's what we're going to do with this. So let's get cracking and let's have a look at the first hypothesis test that we're going to do. Okay, this is our first one on a binomial hypothesis test. The proportion of customers at a busy supermarket that buy tampons is known to be 82%. On a randomly selected day, out of 65 customers, 48 bought tampons. Test at the 10% significance level whether this proportion is unusually low. Okay, so binomial hypothesis test, we need to state P first of all, don't we? So we need to let P be the probability. Shall I give it in context? Yes, I'll give it in context just to make sure this is the full hypothesis test, so doing this correctly, of a customer buying tampons. Okay. So that's the first stage. Next bit, H0, the null hypothesis. Well, the null hypothesis will say that the probability will be equal to 0.82, okay, the 82%. The alternative, well, you want to see if it's unusually low, so it says the probability has to be less than 0.82. Okay. Now, the next bit is we have to assume H0 is true. We assume that the probability is, and we set up a binomial distribution. And what goes in there? Well, it's the 65 customers that's in the question, and the 0.82 probability, because it's the N and the P, isn't it? We want the probability of X being less than or equal to 48. Now we can do less than or equal to on our calculator. So I'll just go and fetch my calculator, 1 second. Okay, on the Casio ClassWiz, we're going to go to menu, we're going to go to number 7 for distribution. We need to go to binomial CD, which is number 1. We need a variable. The X we're going to put in, well, the X we need is 48. The N is the 65, the number, and the probability is the 0.82. And here we go. Let's get this down. It is 0.0654 to 4 dp. Okay, you can see that there on the calculator. So that's where that's coming from. It's coming directly from your calculator. Which, is that less than the 0.1 significance? Yes, it is. Very much less. So, the result is significant. Okay, if the result's significant, what do? Well, we reject H0. Okay. And then our concluding statement, it says there is evidence to suggest we have to give it in context as well, that the proportion of customers buying tampons is unusually low. And that is our hypothesis test. Okay, next one, we'll do it a slightly different method. Okay, so we're going to look at another method using the critical region, but the same question. So I'm going to leave the rest up because we just keep the same anyway. So we can keep binomial distribution and all that stuff. But the critical region method, which is what Excel like to use, is if you hop to your calculator, we're going to find the values of 48 and 49. Okay. If you hop to your calculator, I've just done that, and you get, if you go to your calculator, in the menu mode, number 7, you can go to list instead. It does the same stuff. Okay, and you get 49 as 0.1124. And the other one was the 0.0653. Okay, or 54 if you want to round it up. But the probability is therefore different. So this one, the 48, is actually less than the 0.1. This one is greater than the 0.1. Okay, so this is the critical region, and 48 is in the critical region. And so we carry on with this statement. Okay? And therefore we can say, so the result is significant, rejects H0, and there is evidence to suggest that the proportion of customers buying samples is unusually low. Okay? But it's a slightly different method, but it's the method that Excel like to use. So this is the same method but critical region. Okay, I've slightly changed the question now. So we've got 55 now buying tampons, and it says test at the 10% significance level whether this proportion is unusually high. Now this is different because it's high, not low, but the same principle is still the same. We want now the probability of x being greater than or equal to 55 because we want it to be unusually high. Now to do that, I have to do one to take away the probability of less than or equal to 54, of x being less than or equal to 54, because I can't do the upper end, that upper tail. I can't do that unless you have the numWorks calculator, which I don't physically have because it's proper expensive. So there's distribution again. We go to binomial CD, variable.
Quick note there on the numWorks calculator that I mentioned. It is produced in France. If you did want it, just look to the retail price at $99.99. You get away at the cost for the extra bits that it does. Okay, that's the video.
The x this time is 55, but it's still the same, and we now want 54, don't we? Because we're doing 1 minus it. Okay, so let's get this written down. That is 1 take away 0.63, 0.639, yeah, 943299942. Okay, which is like 0.36, something like that. 0.3606, I want to say, for dp. Okay, now is that greater than 0.1? Yes, it is. So, not significant. So we fail to reject H0. You'd be condoned to write that instead of reject H0. You're condoned to have that. I like writing it like that, but it's up to you. And we write there is, this time, insufficient evidence to suggest that the proportion of customers the proportion of customers, what about it? Buying tampons is unusually high. Now we're going to look at the same problem, but we're going to use the critical region method. Okay, so we're going to do the same problem, but with the critical region method. Now, the critical region method is one we've seen just before. I'll just get my calculator real quick because we're going to need it. So, calculator, Casio class with, I would use the numWorks, but I don't know many people have that, so I might as well teach you off this. So, we're going to go into distribution, so number 7. You're going to pick the binomial, and you're going to pick binomial CD, so they're continuous, and you're going to pick list. Alright, now to get what we need here, we're going to create a little table. Now, my little table, I'm going to create. Hopefully you can still hear me, by the way. I'm going to create my table, and I'm going to put an X column and a P column. Okay, now we're going to need something that goes around it, so we're going to need to test 56 and 57. Aren't we? So we want both of those to test, but we don't know what to test, right? So this is where your calculator comes in. Okay, so you're going to put 56 and 57, right? Then you're going to need your n, so your 55, and your probability 0.82. And we're going to get, give me 2 seconds. There we go, 0.8502 and 0.9182. Hopefully you get those as well, so I get them on my Casio classwiz. So the probability that x is greater than or equal to 57 and the probability that x is greater than or equal to 58. We're going to need both of those to look around what we need. So I'm going to go back to distribution, I'm going to go back in, I'm going to go for variable this time. We want 57 and 0.1498 and a bit, right? Now, is that greater than our 10% significance level? Yes, it is, which is what we want. Now, if we go back and put in 58 as what we want, we get 0.0818. And that is less than 0.1. Agree? So, using our little binomial that we created, the critical region, so what we want will be 58, 59, it's also going to be 60 and all the way up to 65, isn't it? 63, 64 and 65. So it's going to be all those up there, and we have to state that 55 is not in the critical region. Therefore, it's not significant, failed to reject H0. There is insufficient evidence to suggest that the proportion of customers buying tampons is unusually high. And that is how I do it using the critical region method. Edexcel use this method a lot. I don't, because I don't like it. But it is totally up to you whichever method you choose, unless the question specifies to use critical region. Okay, that's how I can do this problem, but using the critical region method. Alright then, so this is a little bit different now. So the question, for the proportion of customers at a big supermarket that buy tampons is known to be 82% on a randomly selected day. Out of 65 customers, 46 bought tampons. Test at the 10% significance level if it is different to 82%. Now the word different here means you have to show that there is a significance. We'll do it twice in the critical region as well after I've done it using the method that many people choose to go down here. So we've got H0, we're going to need H1. This time it's not equal to, but we don't actually know if it's greater than or equal to, so I just put not equal to. Now the mean is going to be quite sneaky here as well, because we're going to take our 65 and multiply it by 0.82, which I think, I'll stick it in here, my calculator, is 53.3. So I think you should get that out. So we assume H0 is true still, and we've set up a binomial distribution. But what's our NNRP? Well, that's still going to be the same as 65 and 0.82. Being careful here. We want the probability that x is less than or equal to 46. Now that we can find out straight in our calculator, no problem at all. So binomial CD, we want 46. And we've got 65 and 0.82, 0.0181. That what we got? Yeah. Reading that from the floor there, at 4 decimal places. Well, is that greater than or less than? Well, it's going to be less than the 0.05, isn't it? So we do that, and then we say the result is significant. So what do? We reject H0. And we do that. And then we say there is evidence to suggest that the proportion of customers buying tampons is different to 82%. Okay, and that is how we can do this using our normal method. Next, do the same one with critical region. Alright then, we're going to do the same problem with critical region now. So this should be a piece of cake really. We want our x and p again. So we're going to hop straight to our calculator this time. We're going to go to CD list. We want 47, 48, 57 and 58, as it is two-tailed, don't forget. And our n is 65 and 0.82. Let that calculate that for a moment here. And we're going to get those there. Let's write those into our little table, shall we? So 47, I get 0.0355. Can you check you're getting the same as well, please? 0.0653, we're going to get 57 as 0.9182, we're going to get 58 as 0.961. Make sure you've got those there on your calculator, and I've put that 9610 as well because we've got the rest to 4DP, we might as well do the same there. Right, now we need the probabilities. So we want the probability of x is less than or equal to 47. Well, we know that's going to be this, and that is less than the 0.05, isn't it? We'll do the same with the x is less than or equal to 48. If it's less than or equal to 48, well, we know that's 0.0653, which is greater than, yeah? Now, if we want the probability that x is greater than or equal to 57, then we can't do that because we need it greater than or equal to 58, because we need to get this value out here of 0.0818, because you have to take one away from the other, don't you? So be careful there. Which is greater than the 0.05, and the same here, the probability that x is greater than or equal to 59. If I just put that in the calculator while I'm here. Take some time to think about it. And you get what? 0.039. Yeah? And that is obviously less than our significance level at 5%. Yeah? So we've got our pieces now. But what we need to work out is our critical region, don't we? Critical region. Now our critical region, I'm not going to write out 0 all the way up, right? I'm not doing that. So I'm going to do 0, 1, 2, and a few dots because I don't want to be writing out every single number. Then we get to the ones that don't follow the pattern, so we get 46 and 47. We're also going to have 59 in there. I'm going to have 60, 61, so we put 60 to 65. And that will be our critical region. Now, also, we have to state that 46, this is in the critical region. Because it's the number that was in the question. That's what we need here. Now, because that's in the critical region, the result is therefore significant, and we reject H0, and then we say that evidence suggests that the proportion of customers buying tampons is different to 82%. And then we are done. So easy when you can get the hang of it, guys. Honestly. People do not like hypothesis testing, but when you get into the swing of this is how quick you can wrap them off in the space of 3 minutes. Alright. We'll have a look at the next one. Don't be alarmed by it, because it's what's called sample means. Now this is not included until we get into the second year. So it's going to use the normal distribution, so looking at sample means. Alright, so if you worry about this, do not be alarmed. This is in year 13 content, starts to make on it year 2 for Excel. And it'll be the same as well, I would have thought, on other examples, AQA, OCR and OCR MEI. Okay? So we'll have a look at sample means straight after this.
Okay, so as I've just mentioned, I have said that I'm going to move on to sample mean testing. Now, I've decided, because that video is getting quite long as I'm editing this, I have decided to split the year 12 and year 13 content up. So for you guys, this is the end of this video now, so if you want to, you can go and watch the sample mean hypothesis testing video, which I'm sure will be out as soon as I possibly can get that out, because that is taking a long time. That's taken a while now. So I do need to figure out how I can get all this uploaded for you guys. I'm literally, it's in the code there, wrote one of the questions out and just completed that stuff there. So I will say, enjoy watching that video, and thank you very much for watching until the very end. And if you are, fantastic. Let me know in the comments if you like these style of videos, these revision videos. There's more to come on here. There's one that I'm planning on doing about tax with the Casio ClassWiz calculator. So that is, if I just reach for this here, that is this lovely beast right here. I also have the NumWorks calculator. Now on the NumWorks, there is some functions that allow you to do the hypothesis test without having to physically write it out. It's quite useful, I find. By the way, the calculator is £150, so you have to work out, is it worth the investment? I.e., if you're not good at hypothesis testing, it might be worth getting. But I want to say, yes, just go for it and buy it anyway, because I don't want to encourage you to buy it. It is on £50, but you got to work out, is the stuff that's on there really for you? Like, do you need the stuff that's on there? Now, if you're doing further maths, it's a great calculator, and I would really recommend you getting that, because the other one, yes, it does have the hyperbolic functions on it, but it is not as good as what the other calculator can offer. Okay? So, end of this video. Go and watch the next one when that comes up very, very soon, and I shall see you all for another mathematics-based video, maybe some more hypothesis testing. maybe a new thing I'm planning on. Can't wait for that when that comes out later on this year. So more stuff to come here in 2022. So happy new year, because I didn't put a video out of me specifically talking, it was just me doing a lot of further differentiation questions. So more calculus to come on here, there's loads to come, I don't want to spoil it too much, but I shall leave this one here, and very best of luck, and I shall see you all in another video. So bye bye for now.